Hi there everyone, I am super excited for the video today because we are going to be cutting up some lithium ion batteries to see how they work. We're going to start with this 380 mAh 60C pack from GNB, which is probably the worst tiny whoop battery I've ever tested. Then we're going to look at this Newbie Drone Nitro Nectar Gold, which is one of the best tiny whoop packs I've ever tested. And we're going to finish up with this 1300 mAh 4S pack to give you an idea of how larger 5-inch size batteries are constructed. Along the way, we're going to figure out why the Newbie Drone pack is so much better than the GNB 60C. And I'm going to tell you everything you never knew you wanted to know about how lithium-ion batteries are made. Let's not waste any more time. Let me get my gloves on and let's get right into it. All right, so let's cut open some batteries. I've got a plastic drip tray and some absorbent towel to mop up any liquid electrolyte that comes out. I'm wearing gloves, as you can see, and I've correctly prepared the batteries. So you probably will never need to cut open a battery, and you probably never should. But it's very important, if you are ever going to disassemble a battery, that it is completely discharged. So I have killed all of these batteries with this lipo killer. And then, as you can see, I've attached a 10 ohm resistor to the battery and left that overnight so the thing is fully discharged. And as I cut this open, I'm going to leave this resistor in place so that there's no chance of any electrical energy building up in the battery. All right, so let's get started on this 380 milliamp hour high volt. So we'll start just by cutting through the outer sheath here. I'm just very gradually going to peel back all of this kind of aluminium foil. There we go. So that pouch has come apart quite easily. And now I can just see inside the pack and see how the connections are made. Looks like all of the connections on this pack are made at one end. So, and there's a bit of tape sort of holding this battery together. So what I'm going to do is I'm just going to cut through the tab that connects this battery to the connector. You can see one of the connectors has already broken. I'm just going to cut this other one. There we go. So that's the pouch with the connector inside. Now we're going to take a look at the actual battery itself. So let's find the end. Just looking at this at the end, you can see how it's kind of rolled up inside itself. It's like one big Swiss roll. So I'm just going to try and find the edge. There we go. And just keep unwinding this Swiss roll. And there we go, all the way to the end. So this battery is composed of just a gigantic roll of cathode and anode material. A layer. We've got a carbon material on the top, and I can lift the carbon off. And behind the carbon, we've got this sort of plastic material. Another layer of carbon black sort of material. And you can see the contact at the end of it as well. So you can see very clearly that at the end of this long black piece of material there is this aluminium strip, and then spot welded onto that aluminium strip is the contact that's going to go to the contact of the battery. So this material here is one electrode, And then this piece of material here, this other black material, is the other electrode. You can see this one's copper. And again, there is the contact that's going to go up into the battery. So there's that bit of copper foil at the end, and then spot welded on is this strip. And then at the end of this strip is the contact that goes up into the connector. So you can see this Swiss roll type construction with a contact at one end and then just all this length of material here. Looking now at the plastic material that's between these two layers, this is going to be this sort of porous polymer material that the electrical current is able to flow through from the positive to the negative side of the battery. And then we also have another plastic layer that's insulating these Swiss rolls from each other so that they don't short out. So you can see that this whole battery construction is just 4 layers. We've got 2 plastic layers, the anode and the cathode layer. So that's the construction of the GNB 380 mAh pack. If you're enjoying the video so far, why not like and subscribe so that you see next week's video as soon as it's available. And if you've watched a few of my videos and would like to support the work I do and support this channel, as well as get early access to new AOS products and links to my full product testing database for motors, props, batteries, ESCs and VTXs, then why not join my Patreon? It'll cost you less than the cost of a cup of coffee and you'll get access to all of that and so much more. There are links down in the video description and I'd really appreciate it if you check them out. Now that we've cut that battery apart, let's see if we can make sense of what we found inside it. Inside the battery were 2 sheets, an aluminium foil sheet and a copper foil sheet. Both sheets were coated with a dark material. The aluminium foil is actually coated with a mixture of lithium, manganese, nickel and cobalt oxides. All of those oxides are ground up, mixed together with liquid to make a slurry or a paste, applied to the aluminium foil and then rolled and dried to produce layers of that material. On the copper foil is coated graphite powder, and sometimes that graphite powder is mixed with some graphene or some silicon, but primarily it's graphite. And that's why the copper foil sheet looks a little darker, if anything, than the aluminium foil. It's because that graphite powder is completely black compared to the sort of dark grey of all those metal oxides. Between the 2 sheets is a porous polymer film soaked in a liquid electrolyte. And that liquid is normally a lithium salt, so lithium phosphohexafluoride, dissolved in an organic solvent. And that electrolyte is there to allow the lithium ions from the anode, from the aluminium foil side, to flow easily to the cathode. While that's happening, electrons will flow through the electrical circuit connected to the battery, and they'll also flow from the anode, the aluminium foil side, to the cathode, the copper foil side. And we can use those electrons flowing to generate light, to drive motors, anything that requires electrical power. So now that we understand the fundamentals of a lithium-ion battery, let's cut open the newbie drone cell and see how they structure their anode and cathode. So we've looked at a lower performance 1S high volt pack. Let's look at one of the best performing tiny whoop packs I've ever tested. This is the newbie drone Nitro Nectar Gold. So just exactly the same as last time, I'm going to try and cut down through the pouch so that we can remove the pouch kind of as one piece and try and leave as much of the battery intact as possible. Start to peel this pack apart. And already I've only got this ever so slightly open. But look at the difference in the construction between this and the GNB pack. Can you see that this isn't a roll type construction? This is layers and layers and layers of material. So that GNB pack was like a Swiss roll all wrapped up. And this has layers and layers of material. So let's open it up a little bit more and see if I can show you more clearly. Trying to only cut through the pouch and not cut through anything else. I think I might be able to get this whole pouch off without the battery actually falling apart. But now let's have a look at the battery. So this looks totally different from the GNB. I can see loads and loads and loads of layers of material in here, all kind of stacked up. So let's cut this open and see exactly how it's constructed inside. There's a little bit of tape on the end. This is like a very thin plastic kind of shroud. All right, so I think to get this open any further, I'm going to have to remove this black plastic connector. Just cut down through this. Yeah, so I'm able to cut through that. But you can see, so that's the connector at this end. But rather than just having one metal tab connecting the connector to the battery, this battery has just dozens of them. Copper tabs on the right, as I'm looking at it, and sort of aluminium foil tabs on the left. You see that? All these layers here, like a deck of cards with copper on one side, aluminium on the other. And those are the tabs that go and connect to the connectors on the battery. So let's open this up a bit more and see how it's actually put together. Look how that's constructed. It's totally different to that Swiss roll we looked at before. What I've got is strip after strip of the electrode material, separated again with this polymer material that sort of provides that interface where the electrons can flow through. And then on the other side, I mean, they're all falling off now, of course, but multiple layers of the other electrode material. And you can see how they would be constructed. They'd just be laid like this. And the electrode material is on both sides, and then there's this sort of gap in between. So you've got electrode, electrode, gap, gap, and then it's a concertina fold to fold all this together. And this difference in the structure, this concertina versus the Swiss roll that we saw before, is really the fundamental difference in the performance of these two batteries. This concertina method is a much better way to make a battery than this Swiss roll. And let's talk a little bit more about that. Having cut apart the Newbie drone pack, we can see that it has a totally different construction to the GNB. The GNB has a kind of Swiss roll construction where you've got those two long electrodes that are rolled up together, whereas the Newbie drone cell has a layered construction with many small electrodes stacked on top of each other. The Swiss roll construction is easier to make. There are only two electrodes that need to be welded, and you only have one contact on each electrode to weld together. And this shape can still be squished flat into a pretty rectangular cell, but it always is going to have a higher internal resistance and lower power density than a layered construction because there's a long current path for those electrons to flow through the copper and aluminium foil before they can actually get out of the battery. In contrast, the Newbie drone method, the layered construction, has many small electrodes that are all welded together in parallel, so the current path is much, much shorter. This pack is more difficult to make. You've got multiple electrodes, they all need to be welded together and connected. You need to make sure that nothing shorts out. But once you've done that, you have a much shorter path for current, and that's going to give you much better power density and lower internal resistance. But what about a higher rated GNB cell? What about this 80C cell? Is that going to have a Swiss roll or a layered cell construction? Or perhaps something entirely different? Let's take a look. Let's take a look now at a higher rated cell from GNB. So this is again a 300 milliamp hour cell, but it's 80C rated rather than 60C. What's really interesting is that this actually appears to be two stacks joined together into a single pack. So GNB are taking what looks like two 150 milliamp hour cells and choosing to connect them in parallel to make a 300 milliamp hour cell. And that's different from what Newbie drone were doing because they just have a single cell rather than these two kind of packaged cells connected in parallel. So this is actually a 1S 2P battery, even though it's only 300 milliamp hours. It's a 1S 2P battery because you've got two cells in parallel. If we look now at the construction of an individual cell, I can just cut these copper tabs off and the aluminium, and that will allow all the layers to separate. Oh wow, so we do have a different construction again to the Newbie drone cell. This is a rolled cell. I thought it would be a concertina, but it's not. This is a rolled cell, but look, you've got multiple tabs on this cell, but it's all the same sheet of material, I think. So there's the protective polymer film between the two. This is the copper foil sheet on the top. Let's take that off. How interesting. So this is the aluminium foil sheet. You can see that it's one piece with multiple tabs. And then at the very innermost part of the roll, they don't have any tabs. They've kind of put extra tabs on to reduce the length of that current path. And on this copper foil sheet, again, we've got multiple tabs, and again, an extra length at each end that doesn't have any tabs on. How amazing. So it's like a multi-tab Swiss roll. I think this GNB ATC rated cell is probably the most interesting because first off, it's not one cell. It's a 1S2P configuration. So we've got two cells in parallel, and each of those cells is a Swiss roll, but it has multiple tabs on each of those copper and aluminium foils. And so there are multiple paths for the current to flow through, multiple ways in which the current can escape the battery, and it reduces the distance that the electrons have to travel through the foil before they can escape out of the battery. So it's a really interesting construction, and we can see that it performs somewhere between a typical Swiss roll with just a single contact per foil and the layered type cell that we saw in the newbie drone. Having cut open two different GNB cells and seen two different constructions, I decided to cut open a 70C GNB cell and a 90C GNB cell. What I found was that the 90C cell has the same construction as the 80C cell. They're obviously just grading the cells and using the better cells for the 90C packs. But the 70C had a different construction again. Let's take a look now inside a 70C rated GNB cell. Oh, that's interesting. What looks to be a single cell in here rather than two cells. So again, this has got multiple tabs. So we've not got the single Swiss roll. So a traditional Swiss roll with just a single tab on each foil. This is definitely multi-tab. Let's see if I can find the edge. So if we unroll this, you can see that again, this is a hybrid Swiss roll construction. But rather than having two cells in parallel, we've just got one cell here. One hybrid Swiss roll cell. And see the multiple tabs on each electrode. It's really interesting that GNB have all of these different constructions for their different C ratings. As we saw, the GNB 70C rated cells have a single cell inside, and it's a Swiss roll type construction, but it's a hybrid Swiss roll because we've got multiple tabs on each piece of foil. So that helps shorten the path length for current flow, gives it performance that's a bit better than a Swiss roll with a single tab, but it's not as good as having two cells in parallel or a layered construction. I think it's fascinating to see GNB using a different construction for each of their different 1S cells. The 60C rated cell has got that single Swiss roll with one tab per piece of foil. The 70C moves to multiple tabs to reduce the internal resistance. And then the 80 and 90C rated cells have two Swiss rolls in parallel, each with multiple tabs to try and lower that internal resistance and shorten the path for the current to flow even further. But none of these constructions quite measure up to the performance that you can achieve with a layered cell technology, like the one being used by Newbie Drone. It's also used by Dogcom and Tattoo in their 1S cells. So if you're looking for the 1S cell that's going to give you the best ultimate performance for your tiny whoop, then you're definitely going to want to look towards a layered construction. So we've looked at some smaller 1S packs. Now let's look at something a little bit bigger. This 1300 mAh 4S. The final battery we're going to be taking apart is this 1300 mAh pack. And this is different from the ones we've looked at before because this is a 4S pack. So we're going to expect multiple individual cells inside this pack. So let's take it apart and see how it's constructed inside. So this is the outer kind of rubber material. And you can already see the silver pouch of the individual cell inside. There we are. So that's the outer rubber layer. Now you can see the individual cells, 1, 2, 3, 4, exactly as we'd expect from a 4S pack. And then we have these really stiff plates on the top and bottom. So these are aluminium plates and they're just there to provide kind of impact protection and prevent anything puncturing the battery. You can see that they stand up really well to any sort of sharp penetration. Let's cut through this and separate the individual cells if we can. I stand corrected. It's not an aluminium plate, it's just a kind of very stiff, hard plastic here. But the job is the same, it's just to protect the battery. I have seen batteries before that use aluminium, but I guess this hard kind of plastic material works just as well. Probably a bit lighter weight also. And then inside we have all of the connections for the balance lead and for the discharge leads as well. So let's take a look at how this is all connected up. So here we have the 4 cells, and they're just connected exactly as you'd expect in series. So positive of this cell, and we've got the negative of the cell down there, which is connected to the positive of the next one. Negative of this cell here connected to the positive of this cell, all the way along, negative, positive, negative, positive. There's a few just little bits of foam in the construction of the pack just to prevent any of these wires shorting out on each other. So that's the individual cells. So now let's take one of these cells and see what's inside it. I'll pick one that I've not bent or crushed too much. So maybe this cell here. So here's one of the cells of this pack. So this is a 1300 milliamp hour 1S cell. And when these packs are assembled, all of these cells are going to be very carefully matched to each other so that they all have the same energy capacity, the same internal resistance, that sort of thing. That's what makes a really good pack, is when the cells are really nicely matched to each other. Now let's cut into this pouch and see how this cell is constructed. Alright, so I don't know if you can see, but I can see the electrodes here. Just at the end, we've got the copper cathode and the aluminium anode here. So, see if I can cut this in a way where those are going to remain visible. So there are the 2 contacts for the battery here. And already just looking at this, you can see that it looks a lot more like the Nubijo Nitronectar Gold construction than the GNB construction from the 1S packs. So I think we would expect that the construction is going to look very, very similar, just on a much bigger scale. Got to be careful, this plastic is very, very flimsy. And sure enough, we have that same concertina type construction. So here we've got the copper foil with a little electrode tab at the top that connects straight to the connector. Then that thin plastic material that blocks the flow of electric current, so these don't short out on each other, but allows the ions to flow between the anode and the cathode of the battery. And then we just have that repeated over and over again. And if you look at these plates, they're double-sided as well. So when you've got, see if I can lift another one up. Yeah. So you've got here a copper plate that is connected, copper plate here, connected to aluminium plate here, and an aluminium plate on the other side. So it's sandwiched between those two. So if I was to build this construction without the plastic in the way, you'd have this aluminium foil, and then there's a copper on top, and a copper on top, and also a copper underneath like that. So you've got twice the surface area because you've got ion exchange on both sides of each of these little sheets, and you just have layer after layer after layer. And the only thing between them is this porous plastic material. Now I'm going to cut these connectors off so that we can unpeel this whole pack. All of these little tabs are spot welded together at the end. You see that little weld there? So that all of those tabs are kind of brought up, folded over, and then welded on the end. So you have all of those plates are all connected together in parallel at this joint here. And then here's I've cut it off now, but here is the same weld for the aluminium plates. And then the battery just peels apart just like a concertina. So I don't know how many layers are in here, but you know, there's tens, possibly even 100 or more layers. So as we can see, that 4S 1300 mAh pack also uses a layered type construction similar to the Newbie drone cells. And in my experience, larger 4 and 6S FPV batteries are all using that layered type construction because as you get to those larger sizes, those larger capacities, the Swiss roll style cells really start to struggle and they're not suitable for flight packs. I hope you enjoyed this video. Hope you enjoyed learning about all of the different types of battery construction and how they affect the performance of the cells that we use for our FPV drones. If you're interested to learn more about which batteries perform really well, head on over to AOS Labs. There's all the summary scores for all the batteries I've tested there. If you want access to all of the deep data, all of the raw information behind those summary scores, then my Patreon is a great resource. It's got all of the detailed data for batteries, props, VTXs, everything that I've tested over the last few years. And you can get access to all of that for just a few dollars a month. So please check out the links down in the video description if you'd like to join my Patreon, support the testing and get access to all that data. That's all I have for you for today. So until next time, I wish you all very, very happy flying.